Hi, welcome to Principles of Communications. In case you didn't know, this is the third installment in a series of video lectures about, Principles of Communications. If you haven't watched the previous videos yet, I highly recommend that you watch it first before proceeding to this part of the lecture. The link to the previous video lectures are provided below in the description. Alright, we have learned from the previous videos about amplitude modulation, or AM. We have learned about when we speak, play an instrument, or literally make any sound waves are generated. We can capture that sound wave by using a microphone, which then converts the sound waves to electronic waves, and then convert them again to radio waves. This is basically what happens during amplitude modulation, and consequently, the exact thing that happens whenever you listen to your radio or watch television. Pretty cool, huh? However, this process has two inherent disadvantages, which leads us to single sideband systems, which are generally more preferable. Recall that conventional AM signals consist of three major parts: the carrier signal and the upper and lower sidebands. Hence, it is also called AM double sideband full carrier system. One inherent disadvantage of it is its power consumption. That is because we are transmitting the carrier and the sidebands altogether at full power. However, only the sidebands contain the information that we need, and the carrier signal is just disposed of afterwards. Ironically, the carrier signal also consumes 2/3 of the total transmitted power, leaving only 1/6 of the total power to either sideband. Also, we only need one sideband, which means that the other one is also just going to waste. That means that 5/6 of the total transmitted power are just wasted, and only 1/6 of it goes to use. Well, that is a lot like leaving the fan on for hours without anyone even using it. That will surely make your mothers totally mad. Another inherent disadvantage of AM is its bandwidth. You see, the upper and lower sidebands are very much unlike each other, and only one of them is being used in retrieving information. This means that using two sidebands just double the bandwidth that we need. This also means that the signal is twice more likely to capture noise or unwanted signals from the environment. Because, let us say that there are noise signals that are present in the range of the lower sideband, and another set of noise signals present in the range of the upper sideband. This will only cause the AM signal to be more prone to disturbances, which we do not like. Single sideband systems are answers to all these disadvantages, having the property of a smaller bandwidth and a lower power consumption. We will learn more about single sideband systems in the subsequent videos within this module. Thank you.